Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. The spaceship left the solar system in 2012 and is currently more than 15 billion miles from Earth.
Now, this is quite a story from NASA because for the second time in history, a man-made object has left our solar system.
NASA making a historic announcement today that the Voyager probe has entered interstellar space, that place between the stars. It's now out beyond the sun's heliosphere.
In the deep, frozen silence more than 15 billion miles from Earth, where the warmth of the sun fades into a ghostly whisper and the planets of our solar system are distant memories, Voyager 1, NASA's oldest, loneliest traveler, has returned from the void with a revelation that no one expected. Not a whisper of static or a routine reading, but something new, something impossible. After months of technical confusion, when it seemed Voyager 1 had begun to slip into senility, spouting gibberish and misfiring its data, its instruments have suddenly realigned. The signals coming in are sharp, coherent, and embedded in that data is something no scientist had prepared to confront. Voyager has reached a frontier that was never supposed to exist, a new kind of magnetic architecture in the region we thought we understood best. The heliopause, the invisible shell separating the reach of our sun from the vast, wild territory of interstellar space. And what it found out there doesn't match any theory we've built in the last century. The outer edge of the solar system was supposed to be chaotic, a frothing border zone where the solar wind crashes into interstellar plasma like rapids in a river. It was messy, turbulent, unpredictable. But Voyager didn't detect chaos. It found order. The data shows a structured magnetic field, coherent, rhythmic, almost geometric, like some vast system breathing in and out. The wave patterns don't align with any solar phenomena. They're not random fluctuations, not leftover noise. They're stable, repeating, rippled in a lattice-like symmetry no one expected to find in a region ruled by plasma storms and particle collisions. This isn't a blurry wall of scattered particles. It's behaving more like a skin, flexible, responsive, and somehow alive. Scientists initially dismissed the signal as interference. Voyager is aging, after all. But when the same patterns were compared with readings from Voyager 2, traveling on a parallel but distinct course millions of miles away, the results were undeniable. Whatever Voyager 1 has crossed into isn't a glitch in hardware. It's a feature of the universe itself. And that's where the real questions begin. If this boundary is structured, what's shaping it? One early theory speculates that dark matter might be involved, twisting gravity into filament-like frameworks that pull charged particles into order. But this assumes dark matter behaves in ways we haven't observed. Others believe this could be a resonance effect, where the magnetic field of the sun is interacting with a secondary, unidentified interstellar field. This would imply that our sun's reach stretches much further, and with more complexity, than previously thought. But there's also another, less comfortable possibility. What if this structure isn't natural? Not in the artificial sense of nuts and bolts. But what if it's the byproduct of an advanced civilization? What if manipulating gravitational or magnetic forces is simply their version of carving stone? It sounds like science fiction, until you consider how unnervingly precise the field structure is. Its spacing is regular, its form is symmetrical, and it doesn't match anything chaotic. If it is natural, it's a kind of natural we've never encountered before. The Voyager data also includes another anomaly, the way cosmic rays behave near this field. Instead of passing through at random, high-energy particles are sharply filtered. Some go through, others bounce off. It's as if the heliopause is selectively allowing energy in or keeping certain frequencies out. And now, layered on top of that mystery is the newest and most disturbing element yet. Voyager 1's instruments picked up low-frequency radio emissions. Not the garbled, wideband radiation typical of the sun. These signals are patterned, modulated. They pulse in a way that suggests intention, maybe not communication, but certainly some kind of rhythm that doesn't belong to any known natural process. They coincided almost exactly with the moment Voyager passed through the most highly ordered portion of the field. It's almost as if the field itself was resonating. Some scientists think this might be evidence of a new kind of plasma-based signal propagation, something that could be used to carry information across interstellar distances, like a whisper passed along an electromagnetic skin. What Voyager has shown us is that we've misunderstood the edge of the solar system. It's not a ragged exit. It's a layered interface, a place that breathes and filters, structures and reflects. That means interstellar travel might require new strategies. If the heliopause behaves like a living membrane, it could interfere with traditional spacecraft systems, navigation, shielding, propulsion. Or, if we're clever, we might one day learn to read its structure, using it as a map or even a means of propulsion. And this changes more than engineering. It changes how we search for life. If star systems are wrapped in these magnetic shells, those shells may shape the flow of organic material, cosmic radiation, or even water vapor from the interstellar medium. They could act as planetary filters, regulating the kind of chemistry that reaches young planets and affecting their ability to nurture life. Life, in this model, doesn't just depend on oceans or atmospheres. It depends on what leaks in and what's kept out. Voyager 1 has crossed a boundary we thought we understood and revealed that we didn't even know what the boundary was. This changes how we draw our maps of the solar system, how we think about our place in space, and how we imagine the future of exploration. We used to think the end of the solar system was a vague and empty region. Instead, it's a gate, a veil, a kind of structured transition between one reality and the next. Not chaos, but pattern. Not decay, but architecture. If that stirs something in you, if that gives you chills, you're not alone. The scientists working with Voyager data are just beginning to understand the implications of what they're seeing. And already, quietly, some are wondering what else we've missed. What lies beyond the veil? Because if Voyager 1 found this with instruments designed in the 1970s, what might we find if we go back intentionally with the right tools and a new set of questions? If Voyager 1 didn't just sail into the void, but into a layer, a shell, of hidden order, then we may have spent decades misunderstanding the very definition of space. And what's now being quietly whispered in backroom discussions of astrophysics labs and planetary science departments is this: maybe Voyager didn't just find structure. Maybe it crossed into someone else's domain. Because in the weeks after those first structured field readings came through, something else began to change. Voyager's instruments, limited though they are, began detecting irregular fluctuations in particle densities. Not random noise, but pulses. Deliberate. Timed. Like echoes. Or pings. And some of those pings came back. That's not a poetic metaphor. That's a literal measurement. The particle oscillations Voyager picked up began mirroring its own emissions. Not instantly. Not at light speed. But delayed. Exactly as though something out there had heard, paused, and answered. The scientific community went silent, at least publicly. Internally, the debate is intense. Some argue it's a coincidence, that the field structures might behave like resonators, that they're bouncing Voyager's own energetic emissions back at it, like sonar in a cavern. But others are no longer so sure, because one of those returns came with a pattern embedded in the signal, not matching Voyager's previous output. A pattern that, when translated into binary amplitude, resembles the prime sequence: 2, 3, 5, 7, 11. Why would a naturally occurring magnetic field send prime number pulses? This is what scientists call a sanity test, the simplest, most universal way to announce intelligence. Not language, not symbols, just math. The one thing that's the same no matter where you are in the universe. Now think back. The only other place we've seen this pattern was in Carl Sagan's imagined contact scenario, a prime sequence echoed through space as the universal handshake between civilizations. Except this time, it's not fiction. This time, it's Voyager. And the message didn't come from inside the solar system. It came from just beyond it, from within that structured, rippling shell we thought was empty. The implications are hard to speak aloud. Because if Voyager triggered a response, then the solar system isn't isolated. It's monitored. Some scientists are now openly wondering if the heliopause isn't just a magnetic effect, but a boundary mechanism, a kind of shield, or filter, or warning perimeter. Not just for physics, but for observation. Something tuned to detect activity and respond. And that's not the only recent data that's raising eyebrows. A sudden shift in cosmic ray detection was logged by Earth-based observatories within days of the Voyager response. Minor fluctuations, barely outside the error margin, but synchronized across multiple arrays. It was as though something was dampening high-energy particles, filtering them before they reached Earth. That kind of coordination, across light years and without delay, should be impossible. Unless, again, what we're seeing is not chaos but control. And this is where the story turns from discovery to something darker. Because if Voyager's message triggered a response, even unintentionally, then we've become the signal. Humanity's first true interstellar handshake may not have been a conscious act, but a mechanical one. A probe crossing a line. And now, something knows we're here. It's no longer a question of if we're being watched. It's a question of by whom.
And why?
Theories, of course, abound. Some suggest a cosmic archive, an ancient automated system, seated across space, recording everything that enters or leaves a given stellar zone. Others believe it could be part of a much older framework, one that predates the formation of Earth itself, watching not just us, but every life form across thousands of star systems. There are those who even entertain the unspoken fear that this structure isn't a boundary at all, but a threshold. And that Voyager didn't just touch it. It may have crossed it, because the readings haven't stopped. The structured pulses are still being detected. The frequency modulations are shifting slowly, almost as if adjusting to Voyager systems. And here's the chilling part. In the latest data batch received, Voyager's plasma wave antenna picked up low-band harmonics not seen before. Harmonics that, when sonified and stretched, bear eerie resemblance to rhythmic tones. Music-like oscillations. They fade in and out, layered, like voices across dimensions we can barely detect. It's not proof, but it is a pattern. And patterns don't happen by accident out here. So what now? What do you do when your oldest machine, drifting beyond all human reach, begins talking to something we don't understand? For now, we listen. The Deep Space Network is now prioritizing every ping from Voyager. Signal analysts have moved off other assignments. Data encryption and routing protocols are being updated to handle any surge in input. And inside Mission Control, teams are debating something they never planned for: whether to reply. Because if this isn't just natural physics, if this is a conversation, then silence is a message too. One team at Caltech has even proposed sending a minimal response. Not a word, not a code, but a simple carrier wave. Something that says, "We received you. We're still here." But others argue, we don't know what's listening.
Not yet.
What started as a malfunctioning probe in deep space has become the most important question in modern astronomy. Voyager 1, the loneliest human artifact, may have uncovered not just a new frontier of physics, but a hidden scaffold stitched across the solar system, and potentially across the galaxy. One that has been waiting, unseen, for us to arrive. And now that we've touched it, we may not be alone in the knowing. Whether this is science, signal, or something far stranger, the message is clear. We thought the solar system had a boundary. It doesn't. It has a gate. Rocket, if that hit you the way it hit us, don't just sit on it. Smash that like button, subscribe for deeper dives into cosmic phenomena, and drop your thoughts in the comments. What do you think Voyager 1 really discovered? An ancient system? A living field? Or are we part of something much older, much larger, and much more aware than we ever imagined? Thank you for watching. We'll be listening too.